Well, hello, everybody. Welcome to a virtual lesson posted by Mr. Sulik. Focus of this week's virtual lessons are going to be on gears and simple gear trains. In this presentation, which I'm going to divide up over a 2-day lesson, we're going to learn about how simple gear train construction and to determine how simple gear train ratios and speed work. Okay, so got a little picture here. We're going to learn about the driven gear and also the drive gear. Okay, so a gear is a form of a simple machine in action. So let's get started. Um, Gears are designed to mesh together and transmit power from one location to another. So that's essentially the definition of a gear. It's designed to mesh together, transmit power from one location to another. The direction of rotation can be changed by using a number of different gears. So if you see how the teeth fit together on this large gear versus this smaller gear, what are some things that might affect the speed or the power of these gears? Think about that. Maybe the number of teeth on each gear, maybe the speed of the driver gear would affect the speed or power. Perhaps how the gears fit together. These gears are tilted on an angle. Okay, some gears are tilted, on a straight plane. The rotation speed of the output gear can be changed by selecting different size gears. So this one and versus this one. Okay, if we change the size of the gear, how might that affect the speed or power? And selecting the correct size and number of gear is important to make machines work and they're required. Gears are toothed wheels used to transmit a rotary or turning motion. So it goes in a clockwise motion. Obviously, it can go in a counterclockwise motion as well. Gears are typically made of metal or plastic materials. They need to be hard wearing for continual use. So even if they are made of plastic, it's a hard plastic because these gears are getting grinded upon. Sometimes they're going in different directions. They're going for a long period of time. The torque that's driven on the driver versus the driven one is over an extended period of time. If one of these teeth break off or bust off, you've got a problem. The gear is not going to be nearly as effective and may not make the machine work. Gears can be found in everyday applications such as clocks, automotive steering systems, electric food mixers. Okay, look around your house, look around some of the things that you have, maybe in your garage. Just look at ask your parents to pop the hood of your car or truck when the car is in motion, or not in motion, rather. Wouldn't be very safe. But when the engine is running, see the belts and how they work together. Okay, gears is definitely an effective, um, complex, simple machine. Gear trains. Gear trains are two or more meshed together. They are used to transmit rotary motions through many gears. So this is important to understand. This is what's called the driver gear. The driver gear is the one that's supplying the power. As this driver gear goes faster, slower, or the amount of teeth will be transmitted to the power of the driven gear. So if the driver gear is going in a clockwise motion, the driven gear, okay, would go into a counterclockwise motion. The driver gear dictates the direction that the driven gear rotates. So if this is going in a clockwise direction, this is going to go opposite of that direction. In the case of two meshed gears, the driven gear rotates in the opposite direction to the driver gear. So whatever direction this is going, this one is going, the driven gear is going to go the opposite of that. An idler gear can be used so that the driven gear turns in the same direction. So I've got a driven, idler, and driver, idler, and driven gear. So basically this is just a small gear goes in between, because let's say I want this driven gear to go into a clockwise motion. Well, in order to do that, I've got to put an idler gear or a secondary gear here in order for it to go in the same direction as this. So I turn here. Oh, back to that. So I'm turning with this one, the driver. The idler goes the opposite direction because this is going in a counterclockwise motion. This will go into a clockwise motion. So take a look at this picture. All right. Pause the video and answer this question. Is the idler gear A, B, or C? Obviously, the answer is B. Okay. Now let's get into the meshing of the gears. In order for one gear to turn another freely and with the maximum efficiency, the gears must be meshed together correctly. So there's just a little bit of space in between here. Okay. It's not too tight, certainly not too loose. It catches the gear. It's going to move this driven gear around with the driver. Correct meshing occurs when the teeth of the driver gear fit halfway between the teeth of the driven gear. So it's halfway here, according to this picture. If the teeth of the two gears are too close together, they prevent each other from turning. So it's too jammed into the driver gear. It's not going to move. I mean, it's going to move, but it's not going to move at the efficiency that you need these gears to be working together. In this picture, obviously, it's just too loose. It's not going to catch it all. Okay, so it's kind of the opposite problem that you have in the second example. So take a good look at these three. Probably figure out pretty quickly which one is correctly matched, and select which one you think is correctly matched. Looking at these, the best answer would be C. So let's talk a little bit about speed of gears. The number of teeth on the driver and driven gears can be used to determine the speed of the driven gear. So I have 20 teeth on the driver gear, 20 teeth on the driven gear. If the driver and driven gears have the same number of teeth, they'll rotate at the same speed. So if I am going at, let's say, 10 rotations a minute with the driver gear, it's going to go 10 rotations a minute with the driven gear. In this example, obviously the driver is nearly 4 times driven. It's got about almost 4 times as many teeth on the driver versus the driven gear. If the driven gear has fewer teeth than the driver gear, the driven gear will rotate faster than the driver gear. So the faster I go, if I go, let's say 20 rotations per minute, this, and we'll talk about the math of it, it's going to go considerably faster versus the first example. If the driven gear has more teeth than the driver gear, then the driven gear rotates more slowly than the driver gear. Okay, so the flip of this, okay, if this driven gear if this driven gear here has more teeth than your driver gear, then the driven gear rotates more slowly than the driver gear. So faster here because of more teeth, slower here because of less teeth. Okay, so again, really determined on your driver gear, on the speed of your gears working together. The ratio between the number of driver and driven teeth is known as the gear ratio. The gear ratio is calculated using an equation. Gear ratio is equal to number of driven gear teeth over a number of driver teeth, gear teeth. Okay, so number of driven, 20 over 10. So if we're to calculate this together, we would take 20 over 10, 20 divided by 10, 2 over 1. Gear ratio is either 2 to 1 or simply 2, just like how you reduce a fraction. The driven gear rotates once for 2 revolutions of the driver gear. This is known as the gearing down. The driven gear is slower than the driver gear. Now we've got gear ratio. If the gears are arranged so that the driver gear has more teeth than the driven gear, this is known as gearing up. The gear ratio can be used here too. So number of driven gear teeth, 10, okay, versus the number of driver teeth, 20. So now we're doing the flip of this. So we're going to reduce this. 10 goes into both. 10 goes into there once. 10 goes into here twice. And then this is written as 1 over 2 or, I'm sorry, ratio 1 to 2 or 0.5. The driven gear rotates twice for every rotation of the driver gear. So for every time the driven gear rotates, it'll rotate twice to every one of these. And that makes sense because this has 10 less teeth than this driver gear. The driver gear has 8 teeth and the driven gear has 36 teeth. So the gear ratio can be calculated. Number of driven gear, another of driver gear. So I'm going to take my driven, 36 over 8. These are going to be 4.5 to 1. 36 divided by 8 equals 4.5 to 1. That means that the driven gear rotates once for every 4.5 rotations of the driver gear. All right, so let's do an example to get, or you do a calculation on your own rather. Okay, we have driven gear, we have driver gear. Get out a calculator, either on your Chromebook or separately, and figure out what you think the answer might be.